In this problem, we're being asked to find an exponential equation. We know 2 points, and we also know it has a horizontal asymptote at y equals 20. So this is going to tell us some very specific things about setting up our equations, and then once we have a system of equations, we'll work to solve for our a and b values so we can write an equation. So notice, here's those key pieces of information. Our 2 data points give us one xy value, another xy value. And this is really important because it has a horizontal asymptote at y equals 20, we know that we use the exponential equation y equals ab to the x, and this plus 20 because our whole exponential equation has been shifted up 20. The horizontal asymptote is 20 units above the y-axis. So this is the equation we're going to use, and we can use these 2 points that were given here to write 2 equations. We're just going to plug in for x and for y. So you can see I've used my xy values to create 2 equations. 22 equals ab to the first plus 20. And all I did was replace x with 1 and replace y with 22. I used substitution. Then I created 20.125 equals ab to the third power plus 20. And again, I plugged in 20.125 for y and 3 for x. Because if those points are on that function, if they're solutions to that function, it means they should satisfy or work when we plug them into the equation. So as we work to solve this system of equations, we have several different strategies we can use, but both of them will want to go ahead and subtract 20 from both sides. So that'll make it easier for our equations to work with. So when I subtract 20 from both sides of my first equation, I get 2 equals ab to the first power. And when I subtract 20 from my other equation, I have 0.125 equals ab to the third. And so one of the strategies that we could use with this system of equations is elimination. And we've done elimination before where we have added or subtracted our 2 equations together. I'm going to use elimination with division. We're going to divide these 2 equations, and that's going to help us be able to find b very quickly. So I'm going to start with 0.125 equals ab to the third, and I'm going to divide by 2 equals ab to the first. And when we simplify that equation, we end up with 0.625 equals b squared, because those a's reduce to 1, and that b cubed over b to the first reduces to b squared. And then when we square root both sides, we find that 0.25 equals b. That strategy allows us to find b really quickly. The other way you could find b is we could go ahead and use equal values method. So you can see that I went ahead and solved each equation for a. If they're both equal to a, then we know they have to be equal to each other. So then we can go ahead and set up this equation. If we multiply both sides by b to the third power, those reduce to 1, and we find that 2b cubed over b equals 0.125. That left-hand side simplifies to we get to b squared, and if we divide both sides by 2, we get 0.625, and again, 0.25 equals b. So we arrive at the exact same place. Now that we know b, we can go ahead and solve for a. I've decided to plug into 2 equals a times b to the first, and so we get 2 equals a times 0.25, or 0.25 times a, and then if we divide both sides by 0.25, we get 8 equals a. So now that I know a and b, I can go ahead and write my final equation. I had y equals ab to the x plus 20, and now I know that y equals 8 times 0.25, or 1/4, you could write it either way, to the x plus 20. And then, of course, if we want to check that, we would want to plug in both of our points and make sure that they work. Let's take a minute and do that. result, and